Welcome back students to the sixth video of this playlist. So in this video we will be solving question number 6 of June 2024 P4 paper. So let's get started. In question number 6, basically this is the second question. Like in the past papers of P4, it's very rare to see two questions from the same vectors chapter. So this is the only recent paper where you can see two questions from vectors on the same paper. So this is the second vector question. So let's see what they have asked for in this question number 6. Okay, so at first, with respect to a fixed origin O, the line L1 is given by the equation. The equation of line L1, it is given as R I plus 2j plus 5k plus lambda times 8i minus j plus 4k. Okay, where lambda is a scalar parameter. Okay, fine. The point A lies on L1. The point A lies on where? L1. Okay, given that, okay, so the point A lies on L1. So we know, since point A lies on line L1, that means the coordinates of point A will follow the equation of line L1. Okay, so given that OA, the distance from the origin of point A, is 5 square root of 10. Okay, fair enough. So the first question, A, show that at A the parameter lambda satisfies this equation. We need to show that. Okay, so definitely you can understand which fact we need to use in this question. That is the distance. Distance is what? O to A, right? So at first let's write the position vector of A at first. So what would be the position vector of point A? So vector OA, that is the position vector of A, would be what? Since the point A lies on the line L1, so we can write what? This equation is the what? Is the position vector for the point A. So this is what? 1 plus 8 lambda, if I write in column vector form. So 1 plus what? 8 lambda. Then next is what? 2 minus lambda. Okay, 2 minus lambda there, and at the end it is what? 5 plus 4 lambda. Okay, 5 plus 4 lambda. 5 plus 4 lambda. Okay, so we got the position vector of A. Now the distance is given, right? So modulus of A would be what? Modulus of A, OA, vector OA would be square root of the square sum of the x, y and z coordinates squared, sum of the square of the x, y and z coordinates, and then whole square root. Okay, so 1 plus 8 lambda, 1 plus 8 lambda whole squared plus what? Plus 2 minus lambda whole squared plus 5 plus 4 lambda whole squared, right? Okay, now expand the bracket. What you will get? A square plus 2ab plus b squared, right? So this is 1 plus b squared 2ab, this is 16 lambda plus b squared is what? 64 lambda squared. 64 lambda squared. Okay, then plus again a square is what? 4 minus 2ab, this is 4 lambda, then plus what? Plus b squared. Plus b squared is what? Lambda squared, right? Lambda square. Okay, plus a square is what? 25 plus 2ab, so 40 40 lambda 2ab plus b squared. So this will be what? Plus 16 lambda squared. Okay. Then it has a whole square root on it. So this will be a whole square root on it. Okay, fine. Now we need to add them. If you add them, what you will get? At first, add the square of lambdas. 64 plus 1, this is 65. 65 plus 16, this is 81. So 81, what? 81 lambda squared. And then the lambdas, 16 lambda minus 4 lambda, this is what? Plus 12 lambda. So plus 12 lambda plus 40 lambda, this is what? Plus 62 lambda plus 62 lambda. And then okay, plus 62 lambda plus what? 1 plus 4, this is 5. 5 plus 25, this is what? 30. And whole square root. Right? Okay, so it is 52 minus 220 lambda. Okay, so this is 1, this is 25, so 26. So 25 plus 1, 26. 26 plus 4, this is 30. Okay, so now we need to equate the length. The distance is given from the origin to the point A. It is given in the question. So it would be, here I think it is 16 lambda minus 4 lambda, this is 12 lambda plus 40, this will be 52 lambda. Yeah, it should be 52. Okay, everything is fine there, just 52. So the distance is given. So what we can write? So square root of 81 what? Lambda squared, right? Lambda squared plus 52 lambda. 52 lambda plus 30. This can be written as what? Plus 30. This is equals to, what's the value given there in the question? This is 5 square root of 10, right? If I'm not wrong, this is 5 square root of 10. So this is equals to what? 5 square root of 10. Okay, so now square both sides. If you square both sides, what will get? 81 lambda squared, right, plus 52 lambda, and then 5 square is what? 25. 25 times 10, this is 250. So 30 minus 250, this would be negative 220. And this is the equation what the question has asked for. Done. Okay, let's see the next part, part B. Hence, that means we need to use this equation. Hence, show that one possible position vector for A is negative 15i plus 4j minus 3k. Okay, so we got the equation. Let's solve this equation. So lambda would be what? Minus b minus what? 52, right? Minus b plus minus what? Square root of b squared minus 4ac. So b squared is what? 52 squared, and 52 squared plus 4 times 81 times 220. Since it is negative 220, so it will be b squared plus 4ac. Okay, so we got 73,984. 73,900 what? 84 over what? B squared. B is what? Over twice of A. So twice of A is 162. 160 what? 62. Okay. Now what would be the value for lambda? Possible values for lambda are, since it's a quadratic equation, so we will get two possible values for lambda. So negative 52, either it is negative 52 plus or minus, okay, 272 over what? 162. Okay, so we got lambda equals to what? Lambda equals to 272 minus 52. This is what? 220 over 162. This is either lambda equals to what? 110 over 81, or the other one is lambda equals to what? Negative 52 negative 272. It is 272 over 162. This is negative 2. Okay, so if lambda is negative 2, if lambda is negative 2, then one possible position they wanted for part 1, they wanted one possible position for A. This is what? OA. If lambda is what? Negative 2, then what would be OA? Let's figure it out. OA was what? 1 plus 8 lambda, right? So lambda, if lambda is negative 2, then it will be what? 1 minus what? 16. So 1 minus 16 is what? Negative 15. Negative 15I, right? And then the value for lambda is what? Negative 2. So 2 plus 2, this is 4j plus 4j. Okay, and then the value for k component is 5 minus 8. So 5 minus 8 is what? Negative 3k. It is when lambda equals to what? Lambda equals to negative 2. Okay, so it is showed. Next is we need to show another possible position for A. This is what? When lambda equals to 110 over 81. So if it is 110 over 81, let's put the value in the equation. What you will get? 1 plus 8 times 110 over what? 110 over, it was 81. So that would be what? This is 961. This is 961 over 81 I. And then what would be the next position? It was 2 minus 110 over 81. This is 52 over 81. So this is plus 52 over what? 81 j. And at the end, the k component is what? It will be 5 plus 4 times 110 over 81. So this is 845 over 81. 845 over 845 over what? 81. This is the k component. Done. So this is the answer for part 1 and part 2. Okay, this is B1 and this is B2. Done. So this is when, if lambda equals to what? 110 over 81. Okay, that's it. Next part is what they have asked in the next question. Okay, the line L2 is parallel to line L1 and passes through origin. So if L2 is parallel to L1, then what would be the case? Their parallel component will be equal. That means the parallel component for line L2 would be also what? 8i minus 4j plus what? 8i minus 4j. So 8i minus j plus 4k. Okay, 8i minus j plus what? 4k. Okay, so this is the parallel vector for what? Line L2, since it is parallel to line L1. Okay, it passes through O. So the initial point is what? 0 0 0, right? 0 0 0 because it is passing through the origin. Okay, so next what they have asked, given that OA is this, okay, the position vector for point A is given, point B lies on L2, point B lies on L2, its distance is given from the origin. Now the question is, find the area of triangle OAB, giving your answer to 1 decimal place. So we need to find out the area of the triangle OAB. Okay, so let's consider one thing. If this is the origin, line L2 basically passes through the origin, right? So line L2, it passes through the origin. Okay, became curved. Wait a minute. Okay, it will pass through the what? It is also getting curved. Okay, let's do a freehand. So line L2, it passes through the what? It passes through the origin. It passes through the origin. Okay, so line L2 passes through the origin, and L1 is parallel to that, right? So L1 is what? Parallel to that. So it will be what? Parallel. Okay, so what we can do, okay, if it works, it will be what? Parallel, right? It will be parallel. Okay, fine. So this is line L2 and this is line L1. Okay, so point B lies on L2, right? So point B lies on L2. Just as a sketch, it is point B, and point A lies on L1. Just as a sketch I'm showing. So we need to find out the area of this triangle OAB. Okay, so OA, the length of OA, OB, both are known, right? So we will just find out this triangle theta. Okay, we will just find out this area, this angle theta, to use the formula half of AB sine theta. Okay, so at first let's find out the theta. So how can we find out the theta? We can find out the theta using what? Using the vector dot product. Okay, for part C. At first the equation of line L2 would be, since it passes through the origin, so it would be what? Since it passes through the origin, it will be 0 0 0, right, plus what? The parallel parameter for L1 is lambda. So for this case we will consider mu. Okay, and since L2 is parallel to L1, so their parallel component would be equal, that is 8 minus 1 and 4. 8 minus 1 and 4. 8 minus 1 and 4 there. Okay, so that is the equation of line L2. Now we need the angle cos theta. So cos theta is between what? It's between the line OA. So OA is what? OA is given there, the position vector of A. This is negative 15, 4 and negative 3. Negative 15, negative 15, 4 and what? Negative 3. So this dot the parallel component of R2, this is what? 8, negative 1 and what? 4, right, over the distance, the OA. The distance OA is given there, right? The distance OA is given as what? It's given as 5 square root of 10, right? 5 square root of 10. So we got the length 5 square root of 10, the modulus basically 5 square root of 10 times what? Times what? Times the modulus of 8, negative 1 and 4. So modulus of 8, negative 1 and 4 is what? 64 plus 1 plus 16. This is square root of 81. Now find out the angle theta. What would be the value for theta? Use your calculator. So dot product, 8 times negative 15, this is negative 120, negative 120, negative 4, negative 12, this is negative 136 over what? 5 square root of 10 times 9. So this is negative 0.95. So cos inverse answer, keep your calculator in degree mode. This is 162.88 something. Okay, this is 162.88 something. So we got the value for cos theta as negative, and since it was negative, that's why we got what? We got 162 point what? 8839 something. Okay, degrees. Okay, so we got the value for theta. Now we can easily find out the area. So area of what? Area of triangle OAB, right? Area of triangle what? OAB. This is equals to what? Half of AB sin theta, right? So AB is what? At first OA, this is 5 square root of 10, right? Times what? The length of OB. The length of OB is given there. The length of OB is given as what? 4 square root of 10. 4 square root of what? 4 square root of 10. And then the value of sin theta. So you can put it directly from your calculator, the value of sin theta. So 162.88 something degree. Okay, so what would be the area? Times 4 square root of 10 times 5 square root of 10 times half times sine 162.8839. So you will get the area is 29.43 something. So 29.430 units squared. Units squared. So they wanted the area to how many decimal places? Only one decimal place. So that should be what? 29 point. The area would be 29.4 units squared. Okay. So the area is, the answer is what? 29.4 units squared. And that's all about question number 6 from June 2024 P4 paper.